Good everyone. So in this video we're going to solve identities on the topic trigonometry. I'm going to use a question which was asked in math 1120. The question was: prove the identity sin 3x over sin x minus cos 3x over cos x is equal to 2. So let's get into it. I'm going to use the left hand side, saying that this is the one which is complicated. So I'm going to say taking the left hand side, so which is sin 3x over sin x minus cos 3x over cos x. Okay, so I'm going to use the double angles on where I have 3x as the angle. So I'm going to introduce sin 3x can also be written in this way. So sin 3x can be written as sin 2x plus x. This is the same. Even this one, cos 3x can also be written as cos 2x plus x. This is the same. So this is what I'm going to introduce here. So here it will be sin 2x plus x in brackets over sin x, then minus, even here I'll introduce that, so minus cos 2x plus x over cos x. Then here I'm going to use the identity for double angle of sine. So when I have sin 2x plus x, this simply means sin 2x cos x, then plus cos 2x sin x, then minus, I'm going to use the identity for cos on this side. So here it will be cos 2x cos x, then cos here we have, if it was positive it will turn into negative, so minus sin 2x sin x. Okay, so this is what I have here. Then here it is over sin x, there it is over cos x. Then I'm going to multiply this denominator by what is on the numerator here, and this one by what is there. In short, I'm going to subtract these two. So to do it simple, I'm just going to multiply this denominator here by what is on the numerator there, even what is the denominator here multiplied by what is on the numerator there. So I'm going to say this cos x multiplied by everything here. So this will be cos x, then sin 2x cos x, then this cos again multiplied by this, so it will be plus cos x multiplied by cos 2x multiplied by sin x. Then we have minus. Okay, I'm going to multiply now what is on the denominator here, multiply by what is on the numerator there. So I'm going to say sine x multiplied by cos 2x cos x. So this will be equal to sine x cos x cos 2x. I've just multiplied sine x by this cos 2x cos x. Then minus, mind you there is minus here, negative multiplied by positive, same as negative multiplied by negative, that is positive. So I'm going to have plus there. Then sine x multiplied by sine 2x cos x, I mean sine x, that is sine x sine x sine 2x. Then what I'll do here, I'll just say over everything, over the product of the denominator. So this whole thing will be over sine x multiplied by cos x, which is sine x cos x. So this is what I have here. Alright, so I can do something here. I can multiply cos x by cos x there. So this will be equal to cos square x, then multiplied by sine x. This will be maintained, sine 2x. Then here I can just rearrange this by saying plus, I can start with cos 2x, then I have cos x sine x. Then here I can also rearrange this as I can start with cos 2x, so cos 2x sine x cos x. Then here plus, I can multiply sine x by sine x, that is sine square x, then multiply by sine 2x. Then everything is over, it is over sine x cos x. So what I can do here, cos 2x cos x sine x minus cos 2x sine x cos x. So this can cancel because this is just 0. Then what I have is cos 2x sine cos square x sine 2x. Then here what I've remained with is plus sine square x sine 2x. So plus sine square x sine 2x. Then this is now over the same denominator, which is sine x cos x. Okay, so I can do some mathematics here by just factorizing sine 2x. So sine 2x will be out since it is common. Sine 2x is common, so I'll remain with cos square x plus sine square x in brackets. Okay, so this is what I'll remain with in brackets. Then over sine x cos x. Right, so at this point now I can say cos square x plus sine square x. This is just when you have cos square x plus sine square x, this is just equal to 1. So I'll substitute 1 there. So I'm going to have sine 2x, open bracket, here everything is just 1 over, here I'm going to have sine x cos x. Okay, at this point now I'm going to use a double angle for sine 2x. This is a double angle, so its identity is simply 2 sine x cos x. That is the double angle for sine 2x. It is simply 2 sine x cos x. Then what I have as the denominator is sine x cos x. So sine x can cancel, cos x can cancel. What I've remained with here is just 1. So what I have here is 2 multiplied by just 1. It is just 2 over what I have on the denominator is just 1. So this will give us just to be equal to 2. So 2 divided by 1 is just 2. So we can say we've proven that sine 3x over sine x minus cos 3x over cos x is simply 2. So this is how you can prove this identity, and this is the solution you wanted to get. So you can just say hence proved. Thank you for watching. Have a great day.